Hi everyone, my name is Hong. My matrix number is B0220100002. So now I'm going to demonstrate on how to use this Xilinx to create our project. So first, we start a new project. Here we give a name, maybe just like demo. Okay, so click next and yes, and make sure here everything is unchanged except this one. If you're going to use Verilog, then we should choose Verilog. Then we go next, finish. Then here we can see this is our project, namely demo. And to create a new module, we right click and click new source, Verilog module, and give a name for module, namely here for example I give demo. Okay, yes, this one just leave it blank. Next. So here we can see this is our space to make our code here. So I'm gonna skip the step to type the code. I'm just going to copy our default code. So after we have finished our coding for our module, then we can click this one, implement the module, and click yes. And this process is maybe take some time, so we have to wait. Okay, done. After the process is finished, we can see here showing no process running. So after no process is running, we can see here the synthesize here is showing a green tick, and the implement design is also a green tick, which means our project is successfully implemented. So next we make a test bench module. Okay, so we right click this new source, choose Verilog test feature, and we just give a name, maybe like test bench. So click next, yes. Here we choose the module we're going to test, which means here is demo. So next, finish. Then after finish, you can see there is a new template here. This is also the space for us to type our coding for test bench. Okay, after this is done, and make sure the unit under test UUT here we change the name because I just implement the code for our real project. So for this demonstration, we're going to change to demo. Okay, so UUT here is the setting for our test bench. So finish, we can click here simulation, unit under test, behavior check, and click yes. And if no syntax problem, they will showing a green tick here. So after that, we can click simulate behavior. Click simulate behavior model. This one is the ISE simulation that generates our timing diagram for the shift register. And here we click this zoom to full view. Then we zoom in until the time range is between 0 to 5 nanosecond. Okay, as you can see, we need to adjust this one, the sequence here. Clock is clear, this one, output at the last. Okay, so we are designing the 5-bit CISO shift register. As you can see, our clock cycle here, after 5 rising edge, 4, 5, this one, the output will show 1, which means At the first rising edge here, the input is 1 because we set it to the input is 1 at the first nanosecond. After 9 nanosecond, our output is 1. And the input we set is 1 nanosecond. And then after 2 nanosecond is 0. Then after 2 nanosecond again is 1. After 2 nanosecond again is 0. At 9 nanosecond is 1. So the input is 1, 0, 1, 0, 1. And as you can see here, the output is also 1, 0, 1, 0, 1. Okay, so that means our output is correct for 5-bit seesaw shift resistor. To view the schematic, we have to change this to implementation. We click this our module, and here we can choose the view RTL schematic, and here we can choose any of this. Okay, so we click add, create schematic, and this is our shift resistor schematic. And this is whole shift resistor schematic. So after we double click it, we can see the flip-flop inside. 5 bits shift resistor means there is 5 flip-flops inside. This one is D flip-flop, which means the data input is 1, then the output is 1. When the data input is 0, then the output is also 0. Okay, so and that's all the flow of using this Xilinx to create and design our shift resistor, and also simulate the behavior of the shift resistor. Thank you.